Good day to our physics teacher, Mr. Peh. My friend Chong SMJK, and I, have done a project about the art of science. In this presentation, I'd like to go over 3 items, which the first is to discover the details about the concept of electromagnetism. Then the second is to make a model based on the electromagnetism. And the third is to exploit the uses of electromagnetism in our daily life. Now I would like to pass my presentation to Chong to show about the materials and procedure of doing the homopolar motor.
So now it's a procedure of making a homopolar motor. What we need is wire, a battery to supply current, and neodymium magnets where the position of the pole is like this, but not like this. You can prepare a cutter knife, a pair of scissors, and a clamp to help you. First, peel the outer layer of the wire to obtain the inner copper wire. You can actually directly buy copper wire instead. Unwind the copper wire to get a single copper wire. Then make the copper wire into the shape like this. Stick the neodymium magnet at the bottom of the battery. Measure the point to fold the copper wire so that it will not too long and touches other things. At the same time, not too short causes it can't cut the magnetic field lines to produce a force. Then it should be working. As it is unstable, fold the copper wire so that it could surround the magnet. Cut the unused part of copper wire. Then it's time to watch the magic. Then it's time to watch the magic.
Hi, I'm Mr. Chi. For our project, I will explain the concept on how homopolar motor works. Homopolar motor works when 2 magnets attack at negative side of the battery, and a copper coil is used to connect the positive side of the battery and the magnets. After that, the coil will start to move around the battery. So, what makes the coil move endlessly? The simple homopolar motor is driven by Lorentz force. Current will flow through the copper wire when placed in a magnetic field which is perpendicular to the current fields, with a force in the direction perpendicular to both the magnetic field and the current. Therefore, a torque is provided around the axis of rotation. Because the axis of rotation is parallel to the magnetic field, and the opposing magnetic fields do not change polarity, no commutation is required for the conductor to keep turning. The Fleming's left arrow is used to find the direction of the force. If the position, battery, or the poles of a magnet are placed upside down, the coil will spin in another direction. That's all from representation. Thank you.
The reminder, also the precaution of this project is the distance between the wire and the battery can be minimized to ensure it cuts the magnetic field lines. We also use neodymium magnet because it has strong magnetic field, and the order of poles, the north and the south, also has to be correct.
Now let us see about the application. So the homopolar motor is common use in generator. They are installed in electroplating process plants. So the generator uses direct current and low voltage, but the current in the motor is high enough to operate the heavy machinery. Now let us see the second one, which is the wind turbine. So the homopolar motor has been used in high torque wind turbine. So our model, which is the homopolar motor, is using electric current and magnetic field to produce force. But this, which is the wind turbine, is using force and magnetic field to produce the electric current. So it can convert the wind into the electricity. The advantages of the wind turbine is the energy produced is low cost and renewable. Okay, next one is the third application, which is the brushed DC motor. So the brushed DC motor are mainly applicable to home-built wind turbine. Power in a brushed DC motor originates from a commutator spinning the electromagnet on the brushed motor as shown at below. So the advantage of the brushed DC motor is it has high efficiency level, which is about 70%.
So that's all for our presentation. Thanks for watching. Bye.